So now we've got the concept of the electric field. Let's look at the electric field formula. So we know the electric field was based on the forces between charges. Is this idea that a big charge can apply a force to other charges, or we can just think about the big field puts out this electric field, and the electric field pushes on other charges. To see how we want to define it mathematically, let's think about this. Let's imagine the big charge is here, and it is big plus Q, big Q, and it's 1 coulomb, a whole coulomb. And a meter away, 1 meter, we've got a little charge, plus Q, and that one is a microcoulomb, 1 microcoulomb. 1 times 10 to the minus 6 coulombs, very small. So we could say, what is the force? Well, we know the formula for the force is Coulomb's constant times 1 coulomb times 10 to the minus 6 coulombs over 1 squared. And I picked numbers that would be easy for me to do real quick in my head. I know that that's 1, that's 1. This is 9 times 10 to the 9, that's 9 billion, and this is 10 to the minus 6. So in the end, this is 9,000 newtons. So if you have a coulomb sitting here and you bring up a microcoulomb, the force will be 9,000 newtons. Now, what if we did this? What if we had our plus Q here, it's still a coulomb, and a meter away, we brought in another small q, but this time we made it 2 microcoulombs. 2 microcoulombs. Well, the force would be blah, 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 same thing. All we did was double little q, so it's 2 times 10 to the minus 16. Everything else is the same. We're just going to double this. Right? We're going to get 18,000 newtons. And we could keep going. If we put 3 microcoulombs there, we would get 27,000 newtons. So you can see whatever the big charge is doing here to create a force, it doesn't really have to depend on little q. I mean, the force depends on little q, but you can see that the force being created by big Q on little q, it's sort of proportional to little q. So what we want to do for the electric field is say we want the electric field to be independent of the value of little q. We want this idea that this big charge is sitting here, it's putting out an electric field that will push on other charges, but the electric field it puts out is independent of those other charges. So we don't want to describe it in terms of the total force, that depends on the other charge. So you can see all we have to do is take that force, F, which is linearly proportional to little q, it has a little q in it, and just divide it by little q. And that would be a quantity that doesn't depend on little q, because it's going to come out of the formula. So this is how we define the electric field. I can put a third bar on there, because we're defining the electric field that way. And if we were being formal with vectors, yes, it is a vector, and force is a vector, and they point in the same direction. But we'll just talk about magnitudes right now to keep things simple. So again, as a reminder, this is the force on little q, and this is the value of little q, the small charge. Okay? So one way to think of the electric field is it is the force per unit charge in newtons per coulomb. So you can also think of it a way, just something useful to help you calculate the force a charge would feel. If I have a field somewhere that's 5 newtons per coulomb, and I stick a coulomb there, it's going to feel 5 newtons. If I stick 2 coulombs there, it's going to feel 10 newtons. Just using this simple equation. You can rearrange it and say F is Q times E. This is usually how we think of defining it when we're thinking this way. So given that, we can get the E field for a point charge. So let's see, E for a point charge, all we got to do is say E, and I'm going to use the subscript big Q to emphasize that this electric field only depends on big Q. It doesn't care about little q. Okay? So E of big Q is defined as the force that big Q would apply to little q over the value little q, the little charge. So we just have to write Coulomb's law. It would be K, Coulomb's constant, big Q, little q, over r squared. Right? That's the force, and now just divide it by little q, put a little q down here. But then you can see it's going to do what we said it was going to do. The little q's go away. And we find that the electric field created by the big charge is independent of little q. It's just Coulomb's constant times the big charge over the separation squared. So if you can calculate that and you want the force for any charge, F equals QE, you just multiply by the charge, the little charge. Okay. So that's mathematically how we create this thing around this charge, E field, that doesn't depend on anything except the charge itself, how far away we are, and a constant in the universe.